My name is Hazem, and today we're going to learn about a fuse disconnect, also known as a heavy-duty safety switch. So this one's special, but basically what this is it's a giant circuit breaker and switch. It's got two safety features in one. So you can see in the on position, our switch is up. So we bring power into the switch from an electrical panel, or basically from an electrical panel, and then we feed a motor like a rooftop unit, or in this case an escalator, but we can feed any number of devices. And now this can be installed at the device. So say somebody is working on the escalator, but they need to cut the power to it first, so they flip the switch. Now this has a lock here, so in order to open this, you have to push the lock in. You can add a padlock to this, and then you can open up the switch. Now, one of the safety features is, if this is in the on position, you cannot open the lid. Now, what you want to buy one of these, you got to look at. So the type, this tells us this is type 1, which means that it's you gotta look at the different types, but type 1, the type refers to the type of enclosure that we have. So this is suitable for like indoor use. If you had a type 2 or type 3, I have to look up the table exactly, but they can be weather rated or they can be outside. But this one, for example, is not weather rated, so you definitely can't do that. It's rated for 30 amps. Turn the light on. Oh, I can't turn the light on. Here we go. So type 1, and it's 30 amps, and it's rated for 600 volts AC and 600 volts DC. So if we turn this off, mind you, now you'll see we've got the wiring diagram, which shows us what we need to do here, and then it's also fused. So these fuses are rated for 30 amps, and you need a fuse puller to get these out. But if we look here, so this is a 3-phase system. So we can do 600 volt 3-phase. Now the fuses are rated for 600 volt AC or 300 volt DC, and they have a 200,000 amp interrupting current, and this one is a 20,000 amp DC interrupting current. So what that means is we've got, if you look at the panel, we've got different knockouts. So in this case, we've made knockouts, and somebody who did this made a mess, and I apologize. But we got power going in and we got power going out. So the power going in comes in through the top here, and then the power flows through these fuses, and then it flows out to our device. So if we get more than 30 amps flowing through any one of these phases, the fuse will blow. And so even if the handle is on, if we get more than 30 amps, this thing will shut off. Now, these are time delay fuses, and it's important that we use a time delay fuse, because what can happen when you turn on a motor, like a big motor, the motor draws it's got a lot of friction when it's at a full stop. So it's drawing a lot of power. So say it's rated for 30 amps, it might draw like 40 or 50 or 60 amps for a few seconds. So if this fuse blew instantly at 30 amps, then when your motor, every time you turn your motor on, you blow the fuses, and you'll never be able to turn your motor on. So actually these are what's called a time delay. So they can last, let's say, 50 amps for 10 seconds. And that'll give you, but past 10 seconds, then they'll blow, which is important here because we don't want to blow a fuse when our motor turns on. But at the same time, these fuses have another interrupting current. So let's say we got 100 amps flows through this fuse, then it's going to blow pretty quickly. Maybe not instantly, but quickly. There's a whole manual on fuses in which fuses to pick. Now the other thing is, this fuse will survive 200,000 amps. So if you get 300,000 amps flowing through here instantly, then this fuse might not protect you. So in here we have all kinds of rules about the bonding. So we have to make sure that we ground our equipment, and we have to ground our box. So the first thing you want to do is figure out what you're connecting. So in this case, we've got an escalator that we're connecting. So this is power coming from our motor, and we've got a connector here already. So we gotta just make whatever hole we need to make. In this case, the escalator constructor made the hole, and then we're just gonna shove our connector in. Now this is a Europe, this is a European wire, so it's colored white, but it actually should be blue, because we don't have a neutral when we connect the motor. So this just fits in like that, and then we had a screw somewhere, and then pause this. So now we've put our screw, our nut in here, and we've tightened this. It's hard to see. I'm gonna tighten that nice and snug, and then we're gonna connect each of these to our lugs. So what do we want to do this? So what you want to do is you want to loosen each of these screws, and then you're going to shove your wire in there. So this is red, black, and blue. This is actually blue, but it's because European. And then you have your ground. So this is your out, and then you're just going to tighten this, and then you're going to loosen the next one. If you loosen it too far, it won't, the screw could fall out. So you're going to shove this in there just like that, and then you're going to tighten it. To do the red one. Whoops, be careful, this one fell out as I was making a video. So you want to tug on each wire to make sure they're secure, all of them, and then you're going to take a cable. So whatever cable you're using, I'm using a tech cable, but you got to think about that you're going to the top here. So think about where you're coming in from, in case the bottom. So I had to strip enough to get over and around. Okay, so now I've stripped my wire, and I've shoved my cable into the fuse disconnect. So I got my ground, which I'm going to connect to my ground. This is the hardest part. Get this in there. And then I've stripped my wires for my top. So this is gonna go red, black, blue, just like before. So we're just gonna shove this in. We want to make sure there's no metal visible, and then I'm gonna tighten the lug. So this one's a bit loose. Don't do that. We want it to be like this. Okay, so now make sure all of these are nice and tight, and you've got your ground, and then you can mount this. So yes, you can mount it first, but in this case I didn't, because we can mount it safely without doing that. And then we just close our lid. Now you're probably wondering why you have a window here, and the reason is you can physically observe that you've got a disconnect. So that's a safety feature, because what if the handle breaks and you think that you've unlocked this, but you actually haven't, then you can open the lid and get electrocuted. So if you have any questions, please post a comment. Thank you.